Good evening folks, tonight we're going to be looking at another AliExpress electronics kit, and I thought it would be interesting to have a look at it and then build it in stages. So it won't be a real time build. I'll stop and start the video as appropriate, and we'll build it in stages like I say. So without further ado, we'll have a look at the kit. Merry Christmas. Yes, please excuse the premature nature of this video, but it is indeed a Christmas tree sort of LED ornament, whatever you want to call it. And yeah, I thought it's an ideal kit for doing with the kids for Christmas, and if I do the video now, it will still give you ample opportunity to order this for it to be delivered in time for Christmas. So yeah, bit of coincidence because Julian Eilert unpacked one of these yesterday in his mailbag video, so we must have been thinking along the same wavelength. So what do we get? We get two PCBs that make up the two-dimensional tree, or three-dimensional tree I should say, and the base plate. This base plate holds the power connector switch, and you attach the battery pack on it as well, and it makes a nice, obviously when you've got three AA batteries in there, it's weighty at the bottom, so it'll give it quite a stable platform for you to set it up on your mantelpiece or wherever you decide to put it. So in terms of the other components, let's have a look at those. Now you may wonder why the components are already all out. Well, I can tell you that when I opened this package up and pulled the little clear Ziploc bag open, or pulled it out I should say, there was a hole in the bottom, and when I lifted it out, basically there was loads of LEDs and capacitors and everything went all over the kitchen floor, and I just wanted to make sure that everything was here before we build it. So what do we get? We'll just go through it. Oops, there's bits going everywhere. We get a nice, fairly good quality 3 AA battery holder. We also get a, I don't know what size that is, 2.5 or something, 2.1mm, whatever it is, DC connector to USB plug, so if you want to power it off your computer at work or whatever, you can do that. Get some resistors, 6 transistors, 6 caps, I think there's about 37 LEDs, 3mm LEDs, various colours, well, red, green and yellow, and little tiny DC jack, and somewhere, yeah, a little latching switch, and there's a couple of screws and bolts to secure the battery box on the PCB. So yeah, that is pretty much it in terms of the components. Look at the PCBs. I do have a slight issue with these. I'll level with you and tell you that straight away. If you look up close here, I test fitted these PCBs, and as you can see, it's scraped the solder mask off the track there, and it's done it on that side, and it's done it on here, and it's done it on here. These boards are a really tight fit, so I have started to do it. I'll finish it off when I pause the video, but I've started to open that up just with a small needle file, just so they don't scrape. And ultimately this is going to be soldered together and secured with solder, essentially welded using solder. So I'd rather have these, quite a loose fit, just to make it a bit easier to assemble and to reduce the risk of me actually rubbing the copper completely off the PCB. Another issue I've got is with actual two PCBs themselves. We can see them marked positive on the right and negative on the left, and if you look at this board here, sorry, I should mention there's no instructions come with this. Now on this PCB you'll notice there's an arrow pointing right and there's an arrow pointing right here, and if we pop that in there, you can see that on the right hand side the positive on the base plate matches up with the positive on the tree. But if we put this other PCB in this orientation, we can see that negative to positive there, and similarly if we put it in that way, it's negative to positive there as well. So I'm not sure what the orientation of these PCBs are. Now the fact that this board has a switch on it, and it has a switched DC jack, it's quite difficult to trace visually. Well, it's not, it confuses me quite honestly. So I think what we'll do is, I'm going to pause the video, I'm going to solder the DC jack and switch on. I'll trace out this base plate so I know which ones go where, which PCB goes in which orientation, and I'll also open these slots up. So that'll be my first job, so bear with me and I'll be back with you shortly. Right, that's the board filed down. I just found it easier, rather than, I did initially try to hold it just in my hand and use a file, but it was taking ages and the board was obviously just flexing. So I found it easier just to put it in this. I've got a small, you know, clamp on vise. It was easy just to clamp the PCB in here, and you know, doing it that way was much easier because obviously the board's rigid and you know you can put a bit of pressure on. While you're doing that, just use the other PCB and then just check that it's moving freely, and of course once that's been done on both boards, you will see that they slot together without any force whatsoever. So the other job I had to do was to trace out the board, and luckily once the connector and the switcher on the board, just using continuity, we've got positive here, so if I, what do we see? Why is that not working? Right, so that's our negative side. Interesting. Ah yeah, and that's our positive side. So yeah, the this silk screen here is wrong. That should say negative there, and this side should say positive. So that was our problem. Right, so next thing to do will be to basically start constructing the boards. So what I'll do is, I'll just take these out obviously first. What I'll do is I'll stop the video and I will start populating both these PCBs. In fact, you know, I'll just populate them all, and then we'll come back to it, and we will construct or join the two boards together, and then join them onto the base PCB. So I shall catch you in a moment. Right, I'm still here. It's some time later. I won't get into too much details on how long this has taken, but it's taken quite a bit. I just thought I'd stop and show you the technique I'm using to fit the LEDs. The longer lead goes into the square hole, the anode that is, and I'm just showing you the way I've been putting them in, because they go sort of, they fold flat onto the board. So what I've been doing is putting them in the correct way. Like I say, anode, the longer lead goes into the square hole in the PCB, and I put it down and then get it to roughly the height, so it's about 3 or 4 millimeters off the board. I then bend the lead over so that the bottom of the lens is flush to the side of the PCB. Get my soldering iron, and on the top, sorry I should say, and using the finger underneath, hold the leads of the LED to keep it in that orientation and flush down, and then just on the top side of the board just tack one side of the LED, and then once I've done the whole row, it's simply a case of going back, hopefully you can see that, yeah, going back over and soldering the other side of the LEDs, and then just touching up the solder from the stuff that's already flowed through from the top side. Anyway, nearly there. I'll be back in a moment. Hi folks, welcome back. Right, that is the two boards completed. Now I will tell you at this point, I have had an absolute nightmare with these resistor values. There was 6 10k resistors on the silk screen, which were obviously easy enough to put in, but the other resistor values, I can't remember off the top of my head. I think there was a 1k, a 2k, a 330, and a couple other values I think, and basically there was no instructions came with this. I hunted around various kits. I searched for the part number, the CTR30B and CTR 30C, and I did find a similar kit. However, it had all clear LEDs, and there were totally different resistor values on the schematic. I resorted, shamefully, by going to AliExpress and looking at various kits of this type, and actually looking at the picture to see if I could make out the colours. I think we're okay. I think we've got them all. The only two that I'm not sure about, the only two I couldn't see in any pictures, is this R7 and R4. So if it doesn't work, possibly swapping these two round might help. But anyway, rambling on again. So it's now time to construct the, get into the final part of the construction. So we'll quickly put the battery pack on. Now what I've done here is I've just stuck a little bit of black insulation tape just to hold the negative side in place. And what we're going to do is we're going to take the black and red wires and put them through the corresponding holes on the PCB. Now these are coming from the underside, and this is just kind of acting as a strain relief, and it's going to make the kit look a little bit tidier. So hopefully this should just sit in place. And while I'm doing this, for those of you who have been watching along, when I was testing the continuity, trying to work out which way the boards went round, I actually, you might have seen a mistake I'd made. The switch was actually in the off position according to the silk screen, but was actually on. So yeah, that was quite annoying, because it was giving us a false reading. So I had to desolder the switch and solder it on 180 degrees, the other way, because it normally open, normally closed, depends on which orientation it was. I'm trying to get this to sit nice and flush. Yeah, I think that'll do. And all we're going to do here is take the little screws, and those just pop into the, through the battery box and onto a little nut on the other side. So we'll just do that now. Hopefully, he says. Now, Julian said in his post bag video that he thought it would take about an hour to do this in real time, and I can assure you I've been doing this for considerably longer. I think I'm probably up to about 2.5 hours now, if I'm being totally honest. And that's not because I'm rubbish at soldering, it's just it's such a time consuming little kit to build. There's a lot of solder joints and a lot of trimming to be done. And of course the whole fault finding, or not fault finding, but actually working out which resistors go in which position did take quite some time. So hopefully at the end of this video we will have a working kit, and what I'll do is I'll give you some good close-ups, so that if you are building this kit you can pause the video and see where each resistor goes. Right, so that's nearly there. What I'm going to do is I don't have my small pliers to hand, so if I can find my big ones, excuse me, here, just grab hold of the nut and just tweak this up. Obviously you don't want to do it too tight because this is just thin plastic and they'll probably just pop through. Okay, just another point to note, sorry, I did put a small lead cut off to add some sort of strain relief onto this DC socket, because there's no sort of mechanical, normally these have a little metal shell around them and it didn't have it, so excuse me, yeah, I just added that. So we're going to cut these leads very short, probably just actually to the edge of the PCB, like so, and then we'll strip these off. like so, and it'll probably be easy to tin them up at this point, or easier to tin them up I should say, like so, and then just using a pair of tweezers or whatever you've got handy. You know, you might not actually need tweezers. Just pop that in there like so. And if we can do this one-handed. Sorry, hopefully you saw that. Got a really bad habit of going off camera and not realising. And that should do the job. Right, okay. So, I've been toying with how to assemble this, whether to solder these together first or whether to solder the bottoms in. And I think probably the easiest way to do it is going to be to solder in the base first. Because if we solder you know, actually join the board first and then it's out of alignment, it might be quite difficult to get these in. So, these go this way. So, wait till we see how can I do this. How can I show you this? Or is it this way? Yeah, I think it's this way. Positive, positive. Yeah, so the arrows, you see the arrows there, they should be basically joined and pointing out the way. Okay. So we know that this side and this side is our positive, if you remember from the start of the video. So we've got positive here and positive there. So this should just pop in, hopefully fairly easily. Yep, and it has. And it's just going to be a case of, if I can get this where you can see it, I'll solder the joint and then I'll show you it. Okay, so if you can see just down in here, a little blob of solder holding that PCB on, and or even just with that one, is fairly strong. So I shall go around and do the rest of the joints. You can tell I'm concentrating because I'm quiet. Right, that seems to be okay. Let's reflow that a bit more. Yeah, that's fairly solid. We've got our connections in the middle, and these are just purely mechanical as well. and we've got a few more just down the bottom here. Again, these are not electrical connections, just mechanical. So I should say this kit was around £3 including delivery to the UK. Let's see, I think it took a couple of weeks to get here. So there's still time to get this in time for Christmas if you want to, you know, do it as a project with the kids, or give it as a gift or something. Maybe a secret Santa present for a geek that you know. And that is pretty much it. There's only one final thing to do, and that is to install the LED on the top. Now we can see at the top here we've got a plus and minus. Hopefully you can just see that in there. So our anode goes to one, to the positive, and the cathode to the negative. Now, for whatever reason, they've decided, as you can probably see here, to put a through hole, a plated through hole at right angles to this. So we obviously run the risk of, you know, joining this like we've done here intentionally, and here our mechanical joints. We run the risk of creating a mechanical joint, and you know, as a follow-on from that, a short. So we're going to have to be very careful about how we actually put this into the board. So I'm thinking possibly, yeah, I think if we just form the leads, and we're going to want as little solder on here as possible. So I'm going to widen these up. I'm just going to use my fingernails to bend them into a shape. Like so. So just check our polarity. That doesn't look too bad there. So we will solder, and we're going to apply, let's say, as little solder as required to avoid any possible shorts. I won't bother soldering the back. I'll trim those leads off. And now, of course, the proof is going to be in the pudding. So, we'll take 3 AA's. These are Duracell Industrials. You've probably heard me talking about these before. They're really good batteries. And hopefully, here goes. Oh, there we go. Doesn't look too bad. Clearly the green LEDs are a bit brighter than the orange, so yellow and red. So I will check those resistor values and just see, maybe swap those two around and see if that allows them to light up more equally. So I appreciate it was a long video, guys, but like I say, it's a nice little project. Yeah, it does have its flaws, a little bit of work and research required to get it working, but yeah, nice little kit, and it doesn't look too bad, you know, pretty cool for what it is and the money it costs. Hope you enjoyed that, guys. If you have any questions or comments, please leave them below, and as always, if you enjoyed this video, found it useful, please like and subscribe. I suppose before I go, what I'll do now is I will actually show you the resistors, and you can pause if required. So this is the orientation with the switch, and there we have it. So try and get that in focus. Okay, and I'll now rotate so that the DC socket is on the left and the switch is on the right, and that is your resistor values there. Like I say, what I'll do is I will put in the comments whether swapping R4 and R7 around make any difference. But yeah, there we have it, guys. Thanks for watching, take care of yourselves, and Merry Christmas.